Joe here. Thanks for visiting Road Trip Joe, and thanks for being my patron. Did you ever wonder about how big the universe is? That's good, because today we're going to find out. Ever since I was a kid growing up, the whole universe thing and how big it is has fascinated me. Not sure why, but I think most boys are kind of taken in with what's out there. And now girls, it seems, as there are a lot more women in astronomy studying what's out there. So maybe the women can figure out what's out there and how big it is, because the men haven't had much luck. But even now, after all these years, I'm still fascinated by what's out there and what we don't know. When I'm out camping under the stars, I literally sit there for hours after the sun goes down, just looking up. I used to know most of the constellations, but today, when I stare up at the sky, I'm just observing what grabs my interest. And even after all of these years of looking up, I'm still blown away by how many stars there are in the sky, which is only a tiny fraction of what's out there, since we can only see around 5,000 or so without a telescope. But what I've never been able to get my arms or head around is just how big the universe is. And just knowing it's really big just doesn't do it for me. I want to know how big. Most of the experts say they don't know either. And then there's some that say it's infinite. That's right, it goes on forever. So if the universe goes on forever, why do they say it's expanding? I mean, they can't even find the sides or even the front door to it. Well, it's the stuff in the universe that's expanding, it seems. That's right. Us, the other planets, stars, and galaxies are all racing away from one another. So, to get an idea of just how big it is, we need to know how much stuff is in there, right? Okay, let's get down to some facts. The age of the universe is approximated at 13.799 billion years old, give or take a few million years, and that figure seems to change the further out they look. The diameter is unknown because they can't see that far out yet, but the diameter of what they can see is 8.8 times 10 to the 26th power. But that doesn't really tell us anything. The mass is at least 10 to the 53rd power in kilograms. And you would be right to say that Joe has no idea how many zeros go into that number. I don't even really know how much a kilogram is. Well, 1,000 grams, I guess, or a little over 2 pounds. Okay, so I do know that one. But I'm guessing 53 zeros go into that total mass number. But that doesn't tell us anything either. At least not something we can wrap our arms around. The universe is made up of ordinary baryonic matter, and dark energy. The baryonic matter is us, our planet, people, stars, and all the other physical stuff we can actually see. But the baryonic matter makes up only 4.9% of what's in the universe. Then there is this dark energy and dark matter. Now, they are guessing on that one because they don't really know what dark matter or dark energy is, because even though they suspect it's out there, they haven't seen it or even detected it as of yet. It's all still theory. But it makes up the rest of the universe, or 95.1% of what's out there. I guess if I couldn't detect 95% of something like the universe, I would make up that dark energy and dark matter too. The shape of the universe, and this one is interesting, the shape of our universe is flat. That's correct, flat, with a big bulge in the middle. And the universe is all of space and time. So I guess the beginning and the ending all exist right now, at this very moment. Our sun is one of hundreds of billions of stars in our galaxy, and they can't even get that number right because some say it's 200 billion, and some say it's upwards of 400 billion. I think there are a lot of stars in the middle where they can't really count them. And it takes about 225 million years for our sun to travel around the galaxy. According to the astronomers and all the other scientists that study these things, this is what's all out there. They used to think there was about 170 billion galaxies hanging around out there. Estimates now put that figure in the 2 trillion category. Yes, 2 trillion galaxies. And many astronomers believe we've only seen about 10% of the universe. There might be as many as 3 sextillion stars in the universe. That's 3 followed by 23 zeros. That's more than all of the grains of sand on Earth. And black holes? Nobody knows this answer, but the estimates run anywhere from 10 million to a billion just in our own galaxy. In planets? Well, nobody knows this answer either, but if you figure that each star, like our sun, has a handful of them, then that would be a lot. But so far, they've only been able to see about 5,000 planets, but that number grows daily. Going by the numbers, or the odds, some have guessed that there might be upwards of 500 million habitable planets in our galaxy. But even the experts will admit it's all a big guessing game. And if you're like me, thinking that with that many potential planets, there has to be life, then think again. A new Oxford study suggests that there is a 53% chance we are alone in this galaxy, and there's a 40% chance we are alone in the observable universe. Man, that has got to be fake news. What do they know? What I did find out while researching all of this, and was news to me, is that Venus rotates backwards from all the other planets, and a day on Venus is longer than a year on Venus. Learn something new every day. Just hope I remember it. Here's one more for you. Your body contains cosmic relics from the creation of the universe. That's right, almost all of your hydrogen atoms were formed in the Big Bang about 13.7 billion years ago. And remember the old days of television? Well, some of that static you saw in that old cathode ray tube were remnants of the Big Bang. And here's a mind number. There are a few experts, smart people actually, who think about this stuff. There are a few of them that say there could be an infinite number of universes. Now, this is more speculative theory than fact, but several branches of mathematics, quantum mechanics, and astrophysics have all come to the similar conclusion. Our universe is just one of many, and we actually exist in a multiverse. But we're only going to measure what we know. So let's do it by distance. As far as distances are concerned, I'm sure you already know they measure how far something is in the galaxy or universe by using light years. Now, if you remember your high school science, a light year is how far light, like the light from our sun, travels in 1 year. That kind of calculation makes it a little easier to understand, I think, with a lot less zeros. To bring you up to speed, let's look at our own solar system. Light travels at 186,282 miles a second. That's a little over 670 million miles per hour. If you could travel at the speed of light, you could go 7.5 times around the planet Earth in 1 second. Now that's light molecules, I think, and that's the fastest thing they know exists. So in a year, light can travel 5.88 trillion miles. I guess now we know why they use light years and not miles or kilometers. Olaus Romer, a Danish astronomer, was the first to successfully measure the speed of light, by the way, and this was back in 1676, 100 years before the American Revolution. So at about 93 million miles away, it takes 8 minutes and 20 seconds for light to go from the sun to the Earth. To get to Mars, it's about 3 or 4 minutes more. To reach Pluto, which should still be called a planet in my book, it takes 5 hours for light to travel out there. So the light that leaves the sun can go over 5 hours out and still not be out of the solar system. Voyager 1 is our most distant probe, and it's 13.2 billion miles away and is going about 38,000 miles an hour. At that speed, it's going to take 40,000 years to reach its first star. I mean, it's not even out of the solar system yet. It has been traveling since 1977. Proxima Centauri is the nearest star to us, and it's 4.22 light years away. So, 5.88 trillion miles in a light year times 4.22 comes out to what? Well, around 24 trillion miles. But you do the math. 24 trillion is close enough. The brightest star in the sky, Sirius A, or the Dog Star as it's called because it's in the Canis Major or Greater Dog constellation, is around 8.6 light years away. The Sirius solar system, which is a binary system with 2 stars, is actually moving closer to us and will gradually get brighter over the next 210,000 years. I guess until it hits us. Now, our galaxy, the Milky Way, is around 100,000 light years across. We are situated kind of far out from the middle of it, but it still takes thousands and thousands of light years for the light from our sun to reach the edges. But what about the other galaxies? The closest galaxy to us, the Andromeda Galaxy, is about 2.5 million light years away. There's one a little closer called the Magellanic Clouds, but it's not a spiral galaxy like the Milky Way and the Andromeda Galaxy. Now, they say the Milky Way is part of this cluster of galaxies and that we kind of hang around together with them. There are around 50 of these galaxies in this cluster, with the furthest one being around 11 million light years away. They also say that the Milky Way and Andromeda will be colliding with each other in a few billion years, but we aren't going to worry about that right now. If we're expanding with the rest of the universe, though, then Andromeda must be going the wrong way, right? So what is the farthest galaxy they've discovered so far? That would be galaxy MACS 0647. It appears to be very young, at least the light we can observe is, and it's only a fraction of the size of our own Milky Way. The galaxy is about 13.3 billion light years from Earth and was formed not too long after the Big Bang, and all they could give it was a number for a name. I would have called it the Faraway Galaxy. And they say that there are plenty more galaxies out there past the Faraway Galaxy. Okay, now, between Earth and the edge of the observable universe is 46 billion light years. So that makes the diameter of the observable universe about 91 billion light years or so across. And so the universe is 91 billion light years wide. So, Joe, you say, why do you even care about this stuff anyways? Who cares how big the universe is? Well, my answer is this: I don't know. But I kind of feel small when I think about it. I wonder if anyone's ever thought about selling some of these galaxies and giving them some names. They used to do that with stars, you know. I'm sure there would be some buyers out there just like there were with the stars. I've got mine all picked out. Oh wait, somebody already does that. Rats. I could have made a fortune. That's all I got. Okay, quick story on Vera Rubin. If you don't know Vera, you should, as she was the first astronomer to actually prove the existence, or evidence I should say, since you can't see it, of dark matter, which we just talked about. It was a huge discovery at the time. She was also the first woman to be able to legally work at the Palomar Observatory. Legally? Really? It was illegal for women to be there or work there? Yes, seems that was really so. And this was in the 1960s, in California no less. But it was a male-dominated discipline, it seems. Vera actually got her doctorate at Cornell and Georgetown because Princeton, where she really wanted to attend, didn't allow women in their astronomy program. Good grief. And Princeton didn't change that rule until 1975. But the 200-inch telescope in Palomar Mountain in California is jointly owned by Carnegie, where Vera worked, and Caltech, and they wouldn't let her use it, at least not without a fight, which apparently she did, so good for her. When she finally did get there, she found out there were no women's restrooms. So, Dr. Rubin taped an outline of a woman's skirt to the image of a man on a restroom door, making it a ladies' room. Dr. Rubin was best known for her work on dark matter, which provided the strongest evidence that it existed, and she did this through studying galaxy rotation curves. She discovered that the outer layers of a galaxy are rotating just as fast as the inner layers. So something had to be pushing that stuff around, and it turned out to be dark matter. Although we still can't see it. It had been theorized back in the 1930s, but it wasn't until Dr. Rubin started studying galaxy rotations that dark matter was given its first real evidence of existence. The Rubin-Ford effect she helped develop with instrument maker Kent Ford is now the standard for understanding the expansion of the universe and has led to many other discoveries since. Dr. Rubin was really the first astronomer to realize that almost 95% of the universe is invisible. During her career, Dr. Rubin studied over 200 galaxies. Vera was also just the second female astronomer to be elected to the National Academy of Science after Margaret Burbridge. Oh, and she was awarded the National Medal of Science in 1993, along with a whole bunch of other awards. Born in 1928, Dr. Rubin worked her entire career at the Carnegie Institute in Washington, where she was a professor. Vera died in 2016 at the age of 88. But Dr. Rubin opened a lot of doors for other women in astronomy, which might be her best legacy. Good job, Vera. That's all I got.